Machine learning models cannot read words. They only understand numbers. Bag of words is the simplest and most foundational technique to bridge that gap. In this episode, we go line by line through what it is, how it works, and how to implement it in Python using scikit-learn. Bag of words represents a piece of text as a collection of word counts. It completely ignores word order and grammar. All it cares about is which words appear and how many times. Each document in your dataset is converted into a numerical vector. The length of that vector equals the total number of unique words across your entire dataset, which is called the vocabulary. Each position in the vector corresponds to one word, and the value at that position is how many times that word appears in the document. The first step is building the vocabulary. We collect every unique word that appears across all documents in our dataset. Here, we have 3 sentences. We split each one into words and collect all unique values into a sorted set. The result is a vocabulary of 8 unique words. This vocabulary becomes the blueprint for all our vectors. Every document will be represented as a vector of length 8, one position for each word in this vocabulary. Each document is now converted to a vector by counting how many times each vocabulary word appears in it. Document 1 contains cat once, mat once, on once, sat once, and the twice. All other vocabulary words have a count of 0. The result is the vector 100011112. Document 2 has a different distribution. Dog and log appear once each. Document 3 has cat, chased, and dog each appearing once. Each vector has the same length of 8, matching our vocabulary size. In practice, you never build bag of words manually. Scikit-learn's count vectorizer does everything in 2 lines. You create a vectorizer instance and call fit_transform on your corpus. Fit learns the vocabulary from the documents. Transform converts every document into its count vector. The getFeatureNamesOut method shows you the vocabulary in order. The toArray method converts the sparse matrix result into a regular NumPy array so you can see the full count matrix. Each row is one document and each column is one vocabulary word. Binary bag of words is a simpler variant where, instead of counting how many times a word appears, you only record whether it appears at all. Setting binary equals true in count vectorizer makes every non-zero count become 1. Here, the word the appears twice in the first document, but in binary mode, it is recorded as 1, not 2. Binary bag of words is useful when the presence or absence of a word matters more than its frequency, such as in spam detection. Once you have fitted the vectorizer on your training data, you use transform, not fit_transform on new unseen documents. Fit_transform should only be called on your training set. On any new text, you call transform alone. This ensures the vocabulary stays fixed from training. Any word in the new document that was not seen during training is silently ignored and dropped from the vector. Here, if a new document contained a word not in the training vocabulary, that word would simply be excluded. Bag of words has significant limitations. Word order is completely ignored, so the sentences the cat chased the dog and the dog chased the cat produce identical vectors even though they mean different things. There is no semantic understanding. The words cat and feline are treated as completely unrelated, even though they mean the same thing. For large datasets, the vocabulary becomes very large, and vectors become extremely sparse, with mostly zeros. Very common words like the dominate the counts and drown out more meaningful terms. These limitations are why term frequency, inverse document frequency, and word embeddings were developed, which we cover in the next episodes. You now understand bag of words, how to build a vocabulary, create count vectors manually, and use count vectorizer from scikit-learn. You also know its limitations. In the next episode, we cover TF-IDF, which fixes the problem of common words dominating the counts by weighting words by how unique they are across documents. If this helped you, subscribe so you do not miss the rest of the series.